observations. The moment whenever we were dealing with a hash set of strings, we saw that the hash set was working fine. I mean, it was detecting the duplicates and there was nothing going wrong in it. But the moment we change the generic type of the hash set to your employee, the duplicates were detected, and this is what should have been detected as false, but your hash set failed to detect the duplicates, and it is all I mean it is not working in a correct manner. So tell me, openly, honestly, is the observation clear to everyone that it was working with the strings and it is not working with employee? Okay, so now we have to go to the next step and understand why. So here, let me give you a very simple statements. Let me make here. When will you say, see, for detecting the duplicates, the hash set has to know when will you say two employees are same. So anyone wants to tell me, when will you say, you have a natural, I mean, it's a very simple question to understand. When will you say two employees are exactly same? Yes, so it's a primary key, the same. So what is the primary key? Employee ID is a primary key. So the moment two employees have the same key, same this. Here, for example, I had made the whole state I had copied. But the primary key is, let us say, employee ID. So if the employee ID is the same, then the employees are considered as the same employees, duplicate employees. Everyone understood me? So now tell me, which is the method which is used for testing the equality of the objects? You know all of it. I'm just trying to ask you. Yes, equals method. So answer the question. Answer the next question. Have we overridden the equals method in the employee class yet? Overridden or not overridden? Answer is not overridden. So when you don't override the equals method, whose equals method it will call for checking the equality? Object classes equals method. Very right. And tell me, all this is a prerequisite. I told you long back, equals method is so important. Equals, compare to very, very important methods. So coming back. So tell me, when will object classes equals method return true? Will it go by reference equality or will it go by the content equality? Reference equality. Very right answer. Very good answer. So here, now answer this. If I ask you, listen to the question, not this, sorry, employees. If I ask you E1 dot equals E4, what will be the answer? True or false? Answer is going to be false, very right, because you have got the inherited. If you're not sure, test it out, confirm. SOP E1 dot equals E4, right? Yes. And of course, the last answer is going to be, check the last answer, false. You got it? Because it is going by, why it is this? Everyone understands, using objects inherited method, using the objects equals, which is inherited method, works on reference equality. So naturally, if you want the hash set to detect the duplicates, what is it we should do? Obvious question. Override the equals. So everyone knows, in the middle of the sleep, in the middle of the night, you should be able to do that. So open the employee class as equals, employee class, and write in the next minute. I'm waiting for a minute. Give me the overriding form of equals method based on this ID equality. Giving you a minute. Write it fast. Don't generate. Write it on your own. You understood the question here? Add writing form of equals based on ID. Do that. We have written this equals method so many times. So just let me know whenever you have done it. Let us see. I got some answer. Public boolean equals this dot object. This is you have this thing. I mean, your method is right, but I hope you have not checked it this. Don't take it from the ID. I hope you have written it. Pushkaraj, it's the wrong one. There's a mistake in the last line. It's a wrong one. Try it out. Check it. You've done the very fatal mistake. We don't write it this way at all. Wrong, Sumit. Wrong, Ankush. Ankush, tell me, is it the overriding version at all? Sumit, tell me, is it the overriding version at all? Should not make such a fatal mistakes after spending so much time on equals method. Both Sumit and Ankush, yours is not an overriding method at all. It's an overloaded method. Did you understand what I said? Prashant, wrong. Not even a single one yet. The correct one. This is the revision. This is the practice you should have done. Wrong. All wrong. So far, all wrong. Super dot equals ID. Wrong, Saurabh. Partially correct, partially wrong. Kannad. Guys, what is wrong with you? Some of you have written the overloaded version. Some of you have written the overriding one, but here you are not checking the instance of at all. Some of you have checked the instance of, but we have said it so many times. I'm really shocked to see all this. Guys, this is a string. So for testing the equality of the string, what is it we use? Do we use the double equal to? We spend so much time on the day of strings. Do you do you test the equality of the two strings with double equal to or equals method? String classes equals. And why you did not remember this, which is so disappointing. Please don't do such a mistake. So I have told you, we have spent a lot of time on this in the first week or whatever of Java. First, for your own understanding, your own checking, those who had said employee, the basic mistake was they had not created the overriding version at all. So all these statements I have made long time back. Public boolean equals, and definitely I'll give you the assignment, which will because this was like a shocker. That is, you have forgotten nothing more than that. So here, this is what is now the full and final correct form. Public boolean equals, you have to have an object. You cannot. What is the rule of method overriding? Method overriding, one of the rule is the argument has to be the same. Correct? So here, let's add. Guys, do it with me. Add in employee equals, because I have a point there. I was expecting everyone to do this properly, but most of you have given me the wrong answer. I think all of you have given me the wrong answer so far. I've not checked the latest messages. Anyway, and here, first checking is instance of checks it, guards it along around your null also. So you don't have to check null and all that. So O, instance of employee, then only there is a point in downcasting. Here, guys, this is a non-generic API. These are the raw types. So you have to, there's no way you can avoid the downcasting here. So we are guarding ourselves with instance of checking. And then you are saying return, what was that? This dot ID, or you can say simply ID dot equals. And here you have the downcast employee O dot ID. Okay. And otherwise, if it is not this at all, employee at all, return false. I'm waiting here for a minute. Correct your equals method quickly. Should not take so many iterations. The first answer itself should have been correct and for everyone. So do this fast. Tell me whenever you have done it. Please add this SOP also. I have a point. I'm insisting because I have a point there. Okay, tell me whenever you are done, then I will ask you to run this again. Done? Very good, Akshay. Don't forget the basics of Java so fast, so soon. Okay, so now I'm asking you, don't run it. I want your answer directly. So if I run this now, what do you expect? I am not asking you all this. These answers are going to be true. So what do you expect to see here when I say emps.add e4? True or false? You expect to see false, but again you are going to see true. This is how we learn the new topic. This is what we will learn, the very important topic. Run it and tell me. Is it adding the duplicate element again? Answer is yes. Is it having the, you can see this. Is it having the duplicate contents? In short, is your hash set behaving as in detecting the duplicates or not behaving as in not detecting the duplicates? It is still not detecting the duplicates. Are you getting me? And what is even worse, what is even surprising, is it calling our equals method at all? Is it calling the overriding form of the equals method at all? Answer is no. So 100% there is something more to the hash set. Have you understood the statements I'm making, guys? See, I'm going, I hope, enough slow. So I asked you to override that itself was a little downer for me because you made so many mistakes in this overriding. But even after correctly overriding the equals method, the problem is the same. What is the same problem? Still the hash set is not detecting the duplicates. Has everyone understood? Has everyone seen the same observation? Got the same output? Okay. So now this is where you start, I mean, that is where you start understanding that there must be something in addition to equals method. And which is that fifth method, which is super important in Java, is hash code. So that is where we get introduced to the last remaining. I told you in the first week, there are 5 methods in core Java, which are the heart of, which are the pillar of so many things. ToString equals, wait a second, Nilesh. ToString equals compare to and hash code. Okay. So here you should not require this frankly, guys, because equals method by now we are in 15th day in Java. You should be able to write it without any problems at all. Anyway, so this is your answer. This is your response. So now let us understand what is happening, what is wrong. The thing is, all answers are given in Java docs. So I want you to read it along with me, and it is nicely explained in the object class. So open the object class API, and here there is a contract which is defined between overriding of equals and the hash code method. So look for the method called as, okay, let's look for the method equals. You know about equals already. Okay, so here, so this is your equals method. Now just check it. So I hope everyone has reached here. It is reflexive. That is, x dot equals x should return true. Simple. Symmetric. If x dot equals y is true, y dot equals has to be true. Everyone knows that. It is transitive. All these things you already know. But here, you have, they have given you all the details. You just have to read it carefully. So here, I'm skipping the rest of the part because I had already explained it long back. Read this note carefully. So note that it is generally necessary to override the hash code method whenever this method is overridden. So is it sufficient? You will say that where we were overriding the hash code. I'll say because we had not yet used any hashing based data structure. So the hashing algorithm, the heart of hashing algorithm of Java is hash code and equals, and there is a contract to be followed. So what is the meaning of contract? Contract is set of rules. So read this. What is the general contract between equals and hash code? Simple statements you remember. The simple statement is equal objects must have same hash code. So the contract says that equal objects must produce same hash code. So this is the contract. This is the rule which is coming from Java docs. So please open this here and tell me, have we followed the contract or have we not followed the contract? Answer is we have not followed the contract. Don't go off track. Let me ask you the meaningful questions and this. So here, let me ask you now. If I uncomment this, can anyone tell me? Focus on the things which I'm saying. Don't go off track. Don't let your mind wander. Be with me because all the answers you are going to get in a couple of minutes. So tell me, what will be the answer here? True or false? Answer quickly. Answer will be even dot equals. People, guys, you need a practice. Skip everything today and first focus on equals method. You are so wrong. What is wrong with you guys? Here, even dot equals E4. Here, we have just this thing overridden the equals method. So tell me, what is E1's employee ID? RND001. What is E4's employee ID? RND001. So what is it going to return? So why are you giving me such shocking answers? So wrong answers. Of course, this is going to be true. So this is going to return you true. But here, answer now carefully. E1 dot hash code and E2 dot hash code. Tell me. So don't answer. Let me ask you the questions. Be little patient here. Don't be hyper. Have we overridden the hash code method so far? Yes or no? We have not. But how come we are not getting any errors? Because we are using the inherited version of your object class. And I have shown you that object class's hash code method. So tell me, what will your object class's hash code method will return? What is it going to return? Object class's hash code method, what does it return? No, wrong answer. That is your toString you are saying. Hash code method, what it returns? The address of the object which is occupied on the heap. So think and answer. Here, are you going to get the same value of a hash code or a different value of a hash code? S or D, same or different? 100% you are right, different. Why? Because the moment you say new, your JVM has to obey you. I hope everyone remembers the memory pictures. How many references and how many objects? 4 references, employee type references pointing to 4 different objects. So this is different. So now tell me, are we following the contract currently? So this is the one of the most important topics. So what is the mandatory part of the contract? The important part, the mandatory part is equal objects, must produce same hash code. So following the contract or not following the contract, we are not following the contract at all. So guys, that is the reason your hashing algorithm is failing. Do these things. This is what people grill you the most, the concept part in interviews. They're not interested in your API mugging or API this. They're interested how well you have understood Java or any technology for that matter. So you can see that equals method, it is calling employee equals method is returning true. But are equal objects producing the same hash code or different hash code? Answer is different, and that is why your hashing algorithm is failing. Okay, so all these things I have tried to simplify with a diagram, a flowchart kind of a diagram, which I'll share with you so that you can look at it. I'm sending you one diagram, and of course there is a solution. Solution is easy. Once you understand the problem, things are not difficult at all. So let me just send you this, the contract diagram. Okay, so I've sent you contract.png. If you otherwise you can look up here. So read this very carefully and mark it as a very important topic in your entire core Java, or to be precise, in your collection framework. So contract between overriding of equals and the hash code. So what is it mandatory for? Today is the day of sets. Monday, I'll start you on maps. So it is mandatory for the E type of a hash set as well as linked hash set. And when I take you to the map, map is all about key and a value. So for the key type of the map, I will say ignore the maps. We will enter the maps later. So here is the contract. The contract has two branches. So here, this is the mandatory branch, a must branch. Ignore the optional branch today. Today means initially. So here, if two references are equal, they could be customer type references, they could be employee type, they could be string type. We don't care. If the equals method returns true, what is compulsory for the hashing algorithm to work is ref1.hashcode must have the same value as ref2.hashcode. You got this? And so this is the basic contract. So has everyone got this diagram? E4. Have I made a mistake? Wait a second. Yeah. Sorry. There should be my mistake. Thanks for pointing it out, guys. Whoever said that, I did not read the name. It should be, but it is. Don't worry. It is still. I mean, it is going to be different. But you are very right. Thanks for catching and telling me, Suyash. Okay, so here it is still different. So we are not saying anything wrong. So point is now this contract we have not followed, and that is why your hashing algorithm is failing. So which method we have already overridden? Equals or hash code? Equals. But hash code, since it is inherited from object, it is not following the contract. So here there are simple steps. So read this. Contract for overriding is for correct working of HashSet, HashMap, hash table, equal objects must produce the same hash code. So you must be wondering how to follow that. You have to override both the methods, as simple as that, but there is a way. So how part? So identify the primary key and override the equals, and based on the same fields, you can override the hash code. But this how part, I'll come to little later. So now I want you to make some changes. So go to the employee class, please. I'll discuss that part in a minute, but I have something else to say. So tell me, which is the method you want to override now? The method to be overridden is hash code. So here, what is hashing? All this will come. Concept will come little later. First is the observation and then is the understanding. So please open Java Docs again, because otherwise how will you know which one? I mean, how to do that? So look for a method, hash code. So here, they tell you right away, returns a hash code value for the object. And this method is mainly supported for the hashing algorithm, for the hash table based implementations. Okay, so there is a full contract, and already they says they give you, if two objects are equal, it should produce the same hash code. So I want you to spend a minute on this hash code method declaration. I hope everyone saw that. So now we are going to override this, add overriding form of hash code to follow. mandatory part. There are two parts. One is mandatory, one is optional. Mandatory part of the contract. Okay. So please don't forget, people are forgetting at override annotation after insisting it so many times. Public end hash code. And here I'm just adding a line SOP in hash code. Please add all this. Otherwise, you'll never understand the internals. And here I'm saying return something like 100. So do this. Do this much. And let me know whenever you have written this. It's just a two-liner method. Have you done it? So now tell me, are we following this part of the contract? Okay, let me ask you this way. Are equal object, is equal object going to produce the same hash code? Yes or no? Are we following the mandatory part of the contract? Yes or no? So you are saying yes. Let us, don't run it. Don't be in a hurry to run it. So please tell me, even somebody pointed out my mistake, even dot equals E4. Tell me now, true or false? Is it going to return true or false? Quickly. Guys, what is wrong with you? There's something very basic wrong with you. People today, I mean, I don't know whether any lab faculties are on the group. Please revise their equals method, guys. People are still confused in equals method. This is going to be true. Why you are making mistake? Equals, it is employees equals method based on ID. So here, if I say even, even's ID is RND001, equals RND001, true or false? So please don't give me wrong answers and make me revise all the things all over again, please. Okay, so this is true. Now tell me, when I say E1 dot hash code and E4 dot hash code, are they going to be same or are they going to be different? Same is the correct answer. And what will be the value you are expecting? Address value or 100? Answer is 100. Overriding form of the method. So this is going to be same. Okay. And here it is going to be 100. So are we following the contract currently? Currently means now equal objects must produce. Answer is yes. And now you run this code and tell me, is your hash set detecting the duplicates as in working correctly or not working correctly? Take 1 full minute and answer. I'm not in a hurry at all. Is it working or not yet working? Duplicates or no duplicates? Answer is it has to work correctly. So see this. In hash code, you can see, I mean, for currently don't worry about that. Added true. Second argument, added true. So you'll say it was also working, added true. Added false. So here, is it detecting the duplicate correctly? Very much so. What is the size of the set finally? 3. And are you seeing any duplicate elements, duplicate employees added or no duplicates? Answer is no duplicates. And this part I already said, it is going. Now, okay, let me ask you, are we following the mandatory branch of the contract? Meaning, are equal objects producing the same hash code or different hash code? Same hash code. What is all this about? Why this is required? You'll understand after we start drawing the diagrams. So currently just take it as the from the Java docs. So this all looks fine. So now go little bit. Everyone has tested it. Anyone wants any code to be shared? Employees were, I mean, test employees that is working fine with you guys. If you need any code, tell me without hesitation. Okay. So now here, so basic, we have achieved the basic job. Your hash set or hashing algorithm, whatever hashing based data structure is working fine. But now, so keep that on a hold. Now let me take you to something like array list, linked list, whatever. Let's talk about array list. And you want to share the code? Nilesh is saying now. So Don't wait for me to ask Nilesh. Tell me anytime you require. So what I'll do is, wait a second, guys. I'll just create a zip of this whole project and send you because I don't know where anyone is lagging. So then I'll ask you my question. I've sent you the entire project. So wherever Nilesh wanted, you can take that. Okay, so let me come back to my question. So here I'm asking you guys, recall array list. Okay, and in array list, let me say, suppose there are 100 elements, 100 references are there, size of array list is 100. And you are trying to search the element using contains method, index of method, anything. So what is the worst case performance? If the, what is the worst case? I mean, how many searches it will take you as the worst case situation? Tell me. 100 searches. Everyone understands it? So this is basically what ON factor. If I make it as 1000, the size is 1000. The worst case figure becomes 1000. So order of n, time complexity for searching will be your O of order of n. Everyone agreed with me? Let it be linked list, like let it be any list. It remains the same. Now I'm asking you here, when you say O of n, time complexity is bad. So why hashing based data structure? Why you learn? Why I hope you have done some hashing based data structures in your ADS course. So what is the benefit of hashing? Tell me. Will it give you the variable time complexity or will it give you the constant time performance? It will give you constant time performance. Everyone understands me? So that is why we apply the hashing techniques. What is hashing and all those things and how it is working internally will come to you after 10 minutes. I'm asking you to observe and conclude. So I'm going, no, Kunal, you are completely off track. I'm not even talked in maps. So why you're talking about key and a value? So resist all that. There's nothing like key and a value here. So here we are talking about a hash set. What you are saying will come up on Monday when I discuss the map. Till maps, there is no key and a value. So all wrong. So now guys, what I'll suggest something. Do follow the instructions and I'm telling you, you'll understand all. So here, make a copy of all these things till the set contains. Okay. And keep it, store it in one text file. I'm opening some new text file. I can send you this text file also. This is what I'm calling it as observations. This I do always for any new beginner, I mean, any beginner batch. So observations. Here, observations of what? Observations when the mandatory branch or here equal object are producing same hash code. Okay. So let me just a second. So here, I'll just give me a second. I'll just make a copy in today's help so I can share. Okay, so here, this is the set of observations. Equal objects are producing same hash code. So here, first statement is, I'll make a statement here. Duplicates are detected. That is, HashSet is behaving correctly. If you have any objections to the statement I'm making, do ask me. So duplicates are detected. HashSet is behaving correctly. But the question now I'm trying to ask you is, look at this and tell me, you can see this, I'll say this much, and tell me, whenever is this add method running in constant time performance or O1 factor or ON factor? Is this adding of the elements happening with O1 or ON? Everyone is understanding why only these questions after doing the entire ADS. Of course, it is a variable time. So can you tell me, if I add, let's say, for example, 10th element, what is it? Will it be O1 or O10? Order of 10. Everyone agrees with me? So in short, here I can say that HashSet is behaving correctly as in it is detecting the duplicates, it is doing the job. But which is the method it is calling in a variable time performance manner? Your choices are hash code, equals, both or neither. Which method it is calling it multiple times for every add operation? Hash code, number of times increasing. Is it hash code or is it equals? Both you are saying. No. You did not understand my English part. Okay. Don't worry. We'll do it in another manner. There are so many ways I can show you. Sorry. Just a second. Wait a second. So let me do something more. So let's do this. You also do it along with me. E5, E6. Okay. And let's say, oh, this I wanted to keep it as same. Observe. You don't have to, if you don't want to type it, fine, don't do that. But I have to do this. And let me just add some more references, please. So let me check, because sometimes, while talking to you, I might make a mistake. E5, E6. Okay, so here, now the answers are going to be different. So please tell me, listen to the question, stop typing. Typing is not important. I can send you this code in a minute, not an issue. So here, tell me first, let me check whether you are with me at all. So let me see whether I have given this 87135. Yeah, right. So tell me, what will be the output here? Fast answer, true or false? It is true. Okay. What about this? E6, true or false? True. What will be the size of the set? New question. Count it and tell me. What will be the size of the set? I'm still getting wrong, different answers. Guys, 1, 2, 3. This is skipped. 4 and 5. So why are you getting me 5 and 6 wrong answers? Just count it properly. And here, of course, you are not going to get no duplicate contains. And this part now I don't have to write. This is fine. Okay. So first confirm that much. Or okay, before confirming. So this is what I'm telling you, 100%. Only this is duplicate and this will be detected. So this is all preliminary things. Are you understanding this much at least? Because some of you gave me the answer 6. Is 5 answer clear to everyone? Unless until I have messed up. 1, 2, 3, 4 and 5. Yes, agreeing or not agreeing? Quickly. Agreeing. Now tell me guys, listen to the question properly. When I'm inserting the first element here, tell me, are you going to see hash code equal both or neither? HC, EQ. Answer that. Here, what is it you are going to see? Wrong answer. Here, you will see only in hash code. Only once. Here, hash code will be called. And how many times? Okay, so will there be any equals method called? There will be equals method called once. Next one. Here, tell me. Hash code is always happening. It is the number of equals method. If you know the word hash collision, that is what is happening. So I was expecting the correct answers after doing entire ADS course. Anyway, that doesn't matter. So here, tell me, how many times here hash code gets called exactly once? The frequency of hash code doesn't change. It is always once. And anyone wants to tell me how many times equals method will get called? Was getting called? Here equals method will get called 2 times. Here, tell me, hash code exactly once. Otherwise, I would have mentioned the frequency. Equals method will get called how many times? 3 times. Guys, equals method. It is the duplicate you have got it. Okay. So equals method gets called one time. Okay, let me say further. Here, element is added. Here element is added, but with one equals method. Here element is added, but with two equals method. Here element is added or not added? Tell me. Element is not added at all. Okay, because the first time itself it says RND001, RND001 equals method returns false. Element doesn't get added. Now tell me here, will element get added or not get added? It's a simple math. Nothing does different. Just counting. Of course, element will get added. But how many times hash code will be called? Hash code will be called exactly once, as always. And equals method will be called how many times? Equals method will get called 3 times. And here, see this? How many times? So tell me. So are you enjoying constant time performance for adding the elements, or is it a O1 factor or ON factor? ON factor. So confirm this much. I'll send you the code in a minute. You just have to, look at it. So here, confirm. Hash code added to. Perfect. Great. Here, hash collision was detected. I am making an assumption that you know these terms. If you don't know these terms, I'm going to explain it from scratch in a couple of minutes. So added true. Here, in hash code, employee equals added true. Because it was a new element. Here, in hash code, in employee equals, but equals method returned true, indicating a duplicate element. So added false. You should understand this output 100%. Here, hashing algorithm is working fine. HashSet is detecting duplicates, but the number of times the equals method is getting called is definitely increasing as per the size of the set. So 100%, tell me openly, honestly, is it a O1 factor or ON factor? Answer is it is definitely the variable time performance ON factor. So are we all clear on the statement? HashSet working fine, but not giving you the constant time performance. So where is the mistake? It's not a mistake as such, but this is not what we came here for. The whole idea behind hashing algorithm is to give the constant time performance. So now open the diagram which I had sent you once again, which is your contract. So I have a question for you. So observations will modify. I'll update that and send you. So answer this question, please. So currently, which is the branch of the contract? Which part of the contract are we following? This I'm calling it as a mandatory branch. This I'm calling it as an optional branch. So are we following mandatory, optional, both or neither currently? Answer with confidence. We are only following the mandatory branch, meaning the equal objects are producing the same hash code. I've not even changed the hash code. I've taken some value 100, change from 100 to 10, 20, 5, 6, 7, anything, same performance you'll see. But are we following the optional but recommended branch of the contract? Meaning different objects should return the different hash code to improve the performance of a hashing based data structure or to ensure the constant time performance. Are we following this branch or are we not following this branch? Answer is we are not following this branch. So here, the different objects are not still producing the same hash code. So if you want to read it from the Java docs, because it is always good. So read this very carefully. All this what I'm saying is 100% important. So this part, see this. Read from here. Equal objects producing same hash code, mandatory part of the contract done. So now read this along with me slowly. it is not required that, it is not mandatory that, it is not compulsory that two objects are unequal, then calling hash code must produce the different results. So I've just written it in a simple English. Unequal objects, is it mandatory to produce the unequal hash code? Not mandatory. But there is a however coming up. Programmers should be aware that producing the distinct integer results into, they say may improve, but 100% it will improve the performance of a hash table. So let me ask you, which is the part of the contract which we have not followed? Mandatory or optional part? The optional part. Are our different hash codes, different objects producing the same hash code or different hash code? They are producing the same hash code. Same, because I've said, somebody said different here. I think there is a problem with my English here. Whatever, irrespective of anything and everything, we are always producing the same hash code. So this is what is causing the problem. So before we fix it, here guys, this has a larger data set. So see what I'm doing. I'm actually, you can take the whole thing if you want. So I'll just say Control A and put it in the observations file. Okay. So I'll remove this and I'll add this. Oh, I should have kept the earlier one. I lost that statement. I can say Control C maybe. Okay, wait a second. Okay, so now if you're confused in that, I'm going to share all this with you in 2 minutes. Equal objects are producing the same hash code. Duplicates are detected. But what is the problem? It is not supplying, or no, you can say not giving constant time performance. And what is the reason? The reason is our different objects are still producing the same hash code. So at least tell me honestly, openly, are you understanding? This is definitely not O1. This is definitely ON factor. So let me send you these observations in a minute and we'll produce. I will continue. Now we'll fix the other part of the contract. If you are already copied it, you can ignore that observations.txt. So now let us read that contract second branch, the how part. So if you want to achieve best of both, as in I want no duplicates to be, duplicates to be detected, plus I want constant time performance, there's a very easy way to do that. So what is that easy way? This is what I had not discussed earlier. So first thing is identify the primary key. What is primary key? The object's identity. So initially I'm starting with a simple primary key. Now you know database jargon. Simple primary key means what? Single field based primary key. So identify that. Later I'll take the example of a composite primary key also. So identify those data members and override equals. And then use the same data members in overriding the hash code. Read this twice. So what are the steps? You ask yourself, what is the object's identity, which is the data member which represents the primary key is equal to unique ID, and override the equals method. And you use the same data member in overriding the hash code. So this is the answer. So now, understand my statements properly. I have already shown you this. So now do things with me. Control-Shift-W, close everything. And let us not confuse between this. So let us create another copy so that you can understand the things. So I'm giving you simple instructions. Click on sets, the whole package, Control C. We are making another copy of the package, and go to SRC and say Control V. Some of you find the copying also sometimes is a problematic. So I can share also. Just give me a minute. So what I'll just keep is string set. Now I don't require. Okay. So remove this. I'll wait for you. Do this much and we will start another copy. This is how I'm going to explain the hashing. I have not yet come to the internals, by the way. This is all API still. So let me know when you copied. from sets to sets 2. Do you want me to send this day 15.1 zip or can you manage this copy? Done. Copied one package into this, and I don't want to see that test string set that we have done already. So just keep employee.java, test employee set.java. Okay. Now let us go a little faster looking at time. So tell me, have we followed? I'm asking you the same boring question. Have we followed the mandatory branch of the contract here? It's a Boolean question. Yes. Have we followed the optional branch of the contract? Meaning, are unequal objects producing the different hash code? No. So can you tell me which is the line number? Tell me the line number in my code which has to change. Everyone with me, some of you have responded, but others I don't know. Line number 31 has to be changed. Okay, so now recall the steps I have told you. What is the step you have to identify is first identify the unique ID. So that is my employee ID. Currently no composite primary key. Composite primary key example I'll take it after the lunch break. So that is your simple primary key. We have overridden the equals. So equals is all good. Now I have said use the same data member, use the same primary key field members in overriding the hash code. So tell me, what should this 100 be replaced by? What should this be replaced by? You're right, line number 30. So I get the answer as ID. There's a problem. Tell me, what is the problem? I accepted your answer, but your answer is wrong. Why there is a problem? See the requirement. Here, I purposefully, I do this, all these things with a point. So it is requiring the int. And what you have got, the type of the ID is a string. And string is not an integer. So, any suggestions? Parsen. It's not required. It's not required. I got it. Parsen, you said convert string into integer using parsen. It's not required. Little bit out of box thinking. Okay, let me give you the clue. When we had created the hash set with string, was it working correctly? Was it working in a perfect manner? Yes. So what is the conclusion? The conclusion is, has your string class already followed the contract between equals and hash code? Yes. So don't trust whatever I'm saying by the tone of the question. When you have Java docs, you don't have to trust anyone. So please open, look for string. So you'll find string. And here, actually you see equals method. This I have shown you, but for the completion, I have to show you this. So this is your overriding form of equals. And it tells you that it is based on the sequence of characters. So if two strings contain the same character sequence, it returns true. You will say we already know that. I know. So here I have got you to show you hash code. And tell me, look at this formula. It's not a difficult formula at all. So tell me, I have shown you the string classes equals method. I have shown you string classes hash code also. So tell me, has string class followed? Your choices are mandatory part of the contract, optional part of the contract. Mandatory means equal strings producing same hash code. Optional means different strings, unequal strings producing unequal hash code. Third option is both of above. Fourth option is none of above. Answer is both. Can you see that? Here it is based on your character codes. So the moment your characters are same, it is going to return you the same hash code. Simple. And the moment the characters are different, it is going to return you the different hash code. There are some very rare combinations where different strings can still produce the same hash code. I've given you these combinations. We'll come to all of that. It's very interesting to see that. So consider those rare cases. Don't consider them correctly. So this is fine. So now after saying all these things, anyone wants to help me? What is it I can use? What is the solution here? See, I can give you the solution in a minute and finish it off. But if it comes from you, it stays with you. Exactly, Ritesh is right. So why don't you use, here we have used the string classes equals method. So what stops you from using the hash code of the string? It has already followed the contract. Okay, so make a correction and say that id.hashcode. So now tell me, are we following the both parts of the contract or only the mandatory part or optional part or whatever? Both parts of the contract. Everyone with me? So I'm going, I hope sufficiently slow. So your equals method I did not even touch. It is full and final. But here I changed the id.hashcode. Now you simply run it. Okay. So that is why I asked you to create another copy. So you will have two different set of observations. So run it, guys. And tell me, I'll give you a minute. And just copy this. Okay, anyway, forget that copy and all. So run it. Has everyone run it after modifying the hash code? Because I'm going to ask you the questions. Okay, so first question. Is it detecting the duplicates? Is it working fine or is it keeping the duplicates? Working or not working? It is working fine. No duplicates. Great. And now the most important question is it working in a constant time performance or O1 or ON? Are you understanding it? See, it took me so much time to explain, and that too I have just explained the half where we have drawn the diagrams and understood the internals. But can everyone understand it? So here the equals method is, of course, you will say it's called here once because there was a duplication. But in all other cases, is your JVM investing or wasting time in calling equals multiple times? Absolutely not. Okay, so for your own benefit, all this is very important discussion, trust me on that. So just copy this, and if you don't copy, fine, I'll still send you this. So now I'm just drawing a HR, I mean horizontal rule, and here I'm saying is giving you this set of observations. So let me say this loud and clear. I mean, I'll give it in this. Equal objects are producing the same hash code, and unequal objects are producing, I'll give you this in a minute, okay? Are producing different, or you can say distinct, whatever, different hash codes. So duplicates are detected, HashSet is behaving correctly, and also giving constant time performance. So I'll send you this file. Oh, okay, observations or text. I mean, you can do yourself also the job, but this is what is telling you that now you have achieved both. The detection of duplicates is also done. 15.2. I have not created a widget 15.2. It's 15.1 still. I just made a copy of package. I'll send you that 15.1. Abhijit, I think you got this 15.1 itself. I'll show. I just created another package. I'll send you that in a minute. Wait. So here I'll make a zip again. 15.1. Add to archive. And let me send you this once again, Abhijit. So you'll have, now look at the project, package sets 2. So open that sets 2 and then look at it. You're most welcome. So this is what you should look at. So observations are at least, I hope, clear. So now let us spend some time in understanding what is the internal and what is that hash code contract and everything. So now I think I have given you the code also. I've given you the observation file. Now we have to understand the internal. Looking at time, I think I'll start the explanation and we'll continue it after the lunch break also. So high time to draw the memory diagram. So here when I say memory diagram, all these earlier days we were drawing stack, heap and method area. So this case, I want to show you the internal working. I'll give the title. So leave the coding part, open either pen or your piece of paper and definitely draw the diagram. See, I have got the final version of the diagram ready. I've been doing it for years. But I would say draw it along with me so you'll understand each and every part and you will not, you will not feel lost. So let's give the title internals of hashing algorithm. Hashing algorithm followed by which data structures? Followed by naturally hashing based data structures. DSS for data structures, hashing based data structures. Example I'm giving. So the example currently we are saying is HashSet. LinkedHashSet is a subclass of this. So LinkedHashSet also follows the same. Then you will see a class. We will not actually use it, but you should know. There's a class called as hash table. Then the most important one for advanced Java, for web programming in Java is HashMap and also LinkedHashMap and many more. Today is not the day for maps. Today is day of sets only. But the hashing algorithm which I'm discussing today and which I'll revise on Monday is going to be the same between a hash set and a hash map. You will see hash set internally maintains nothing but a hash map. So this is the important diagram you're drawing. And here I'm not going to draw the stack that the heap, stack and method area. Our focus will be on the heap. But before I say anything else, let me just, write some code here. HashSet, and let's say employee adjust. You don't have to, I can share this diagram, but at least don't have to write the code part, but write diagram part, please draw. So new HashSet. And then I'm saying SOP and all I'll not add. Just a second, I'm just thinking about it. Okay, I'll add that also. Takes time, that's why I was hesitating. Employee something. And this may not be exactly same as this. The name and all does not matter really. If there are some bracket mismatches and all, 1, 2, 1, 2, 3, one more thing, I guess. Anyway, so point is just understand. I am not taking too many examples. I'm just solving a couple of them. Okay, so something, and here I don't care about this, so it doesn't matter really. Just give me a minute to add on this. It is not add, and here let me just say something here. I'm just thinking about it. It is not add. This is fine. And here, I'm just thinking whether I should do it in 2 versions or not. So let's say, yeah, assume that mandatory part only mandatory part of the contract is followed. That is the hash code I'm returning is, let's say, 100. Okay, so this is the given. So what I'll do is, if you want, I can send you this much of a diagram directly. So this is something else. Okay, so let me just save it. So if anyone is drawing it in paint, they can avoid this step. But rest of the things, please draw along with. Otherwise, you won't get a feel of it. Okay, I've sent you this hashing internals. If you want, you can, or you can draw it on a piece of paper. Whatever suits you is fine for me. So now looking at time, it is almost like one lunch break. Just one line I will explain and we'll stop. So here now, okay, let me ask you. Have you reached here understanding wise? That is, what is it we are discussing? You have understood it. And here I'm solving it with the only mandatory part of the contract. Done. That is, you remember that observations files I have already sent you. So I want to show you why it is a variable time performance or what is it happening internally. That is the first part. And then you can understand when you start the optional part, how it improves. Everything will be clear. So just little bit I'm explaining and stopping immediately for a lunch break. So let us execute the statement by statement. So the control is on the first line of execution. It is right hand side RHS associative. So here we are creating the object of a hash set. So what I'm going to show is, I'm not showing a method area. If you want to draw the method area, hash set class is loaded in the method area. And what I'm showing you is only the heap. So now guys, be careful. Be clear. So what I'm showing you is only the heap part of the memory area, and leave one half for heap and other half, you divide the page into two parts or something, or you can draw it in two pages. And this is where we are going to draw your flow chart for hashing algorithm. Okay, so keep it separate. So this part I will start drawing after the lunch break. So I just want to show you one simple thing. When this line is executed, what is it which is happening in a hash set? So before I can take you further, there are couple of things. I had said this earlier. Size is of course 0, but there is something called as an initial capacity factor. So this initial capacity, what is the size? What is the value of the initial capacity? Default is 16, and later we'll consider something called as a load factor of 0.75. Oh, sorry. So ignore that 0.75. So initial capacity 16. So here, this is where the hash table gets created. So here show nothing but, what is hash table? Nothing but array of references, array of pointers. So here show in the heap, the first line, I'm going to draw only one line and stop here for the lunch break. So here you show nothing but array. And when I hope you remember how we used to draw the array. So the first slot of any Java object is class pointer. I'm skipping that. Class pointer will point to the loaded HashSet class. Then is the length of the array. What will be the length here? 16. So here I'm directly drawing the slots, which are called as buckets, which you already must have heard. It is called as bins as well as buckets. Different authors use different terms. So start showing the slots here. I'm not drawing all 16 slots, just drawing a couple of them. And then like, so you can have this, but you draw it. Not all, of course, all this. So tell me, what will be the value of the indices ranging from? It is going to range from 0 to 15. Everyone should know that. So it is nothing but your 0. The indices are going to run from. I'm not drawing the class pointer and the length. Please don't misunderstand my memory picture. This is your 2. Then there is a 3 here. And then there is something called as. And last one, you show it as 15. Okay. So this is nothing but your, this is called as what? Nothing but your hash table. This is called as a hash table, which is nothing but array of references. Okay, array of references. Now, further clarity, just like one thing. This individual slot is called as a bucket. So I'm giving everything in writing. So this individual slot, this slot is nothing but referred to as bucket. Some authors call it as bin. So generally I use the term bucket. Bucket or bin is the same. And here, what is it going to contain at the Poron condition? It's an array of references. So what it will contain, guys? What it will contain? The default initialized value. Absolutely correct. Null. So this is going to be initialized null. Okay, so here when you say hash set h is equal to new hash set, what is this array of references going to initialize is to a null value, and null value indicates nothing but empty bucket or a populated bucket. I hope everyone understands it. It is nothing but your empty bucket, or you can say empty bin. But now you have done, thankfully, the data structure course. What is it going to be later? Here, it is going to be nothing but going to contain later. Later means when you add the elements. When you add the elements, it is simply going to contain, the elements are going to be get added in form of nodes. You know the nodes. When I say node, what it reminds you is a linked list. So when you add the elements, it is going to add, it is going to contain, then it will contain, you tell me logically, the address of the head node or address of the tail node. What is it going to contain? The address of what? It is of course going to contain the address of the first node. It will contain the address of the, or you can say reference to the address of the first node, which is nothing but the head position node. And before stopping for the lunch break, already people are dropping off here. So here, what is the structure? I'm going to show you later. Later means on Monday, the internal code of your, Java source files and all that. So that node is going to consist of three things. Yes, it is going to contain a hash value, a hash. Then it is, pipe is just a separator. It is going to contain, it is, okay, so this node, I'll add one more line here before I give this. This node is going to be added, will be added to a singly linked list or a doubly linked list. So here, hash table maintains singly linked list. So he will be added to a singly linked list. Okay, so this is what is the basic thing. I'll of course repeat this after the lunch break. Will be added to a single linked list. So now you'll understand. So what it will contain is nothing but the hash value. Then it will contain the element. When I say element, element reference. And then what will it contain is, is the pointer to the next node. So this is what your node is going to actually consist of. So I'll just save this and send it your way. Before that, I'll just give you a quick recap. Hash table, when you say hash set, h is equal to new hash set, all it is created is nothing but an array of references containing the values. I'll just give you the idea so that it is nothing but containing all 16 nulls. Okay, initialized to null. What is it going to contain? Initialized to null, empty bucket. When you start adding the elements, then it is going to contain the address of the head node. And if you go into the depth and see what is this node going to contain, consist is, it is going to store your hash value, the reference, element reference, employee reference, even E2, E3, E4, E5 types, and the pointer to the next node. So this is your initial basic power on conditions. Let us stop here for a lunch break. And after lunch break, so it is 1:39. So we will resume at 2:40. I'm giving you 1 full hour to recover. So around 2:40 we'll resume. So I know, Piyush, sorry for stretching it a little bit. So tell me, do you want this diagram? Shall I send you this so that you can look at it, or you can this? Okay, I'll send you this diagram and we'll continue with this diagram after 1 hour. Just a second, I'm sending you. So hashing internals, so that you can sync up, and after lunch break, which we will start around 2:40, we will continue with the remaining statements. That will be all. See you after lunch.